Our next example, we are going to look at the Laplace transform of a unit ramp. So the function is t. Now, a little bit about the unit ramp. A ramp input is assuming that you have a system, right? This is our system, and your input here is a ramp, and this is your output. So a ramp is, if you want to, for example, test the velocity or the speed of a vehicle, your input will be your pressing the pedal, and as you press the pedal, your velocity will increase linearly like that. And this input here, this is your ramp, and we are going to find the Laplace transform of the unit ramp input. So what we are going to do is we are going to write down our Laplace equation. So what we want is the Laplace of t is equal to integrating between 0 to infinity t times e to the minus st dt. Let me just clean off this. So again, having this equation, you can see that we have an exponential multiplied by t. And the easiest way to solve this is we need to use our integration by parts again. And remember, our equation for the integration by parts, it was, we want the integral of u times dv, which is equal to uv minus an integral of v du. So here we can let u is equal to t, so that we have the du is equal to dt. And we can take our dv is equal to e to the minus st dt, and the antiderivative of that, which is your v, is equal to minus 1 over s e to the minus st. So we have this nice information here, and we are going to use it and substitute into our equation. So what we have is u, we have u is t, so you have t times v. V we have minus 1 over s times e to the minus st minus integral between 0 to infinity. V we have again minus 1 over s times e to the minus st, and du is just dt, so times dt. And now is just to clean up the equation just by doing the algebra. So we are going to have, I'm going to work out on this. We have minus t over s times e to the minus st. Negative and negative is positive, so we're going to have plus, and we can pull the 1 over s on the outside of the integral to give us this 1 over s, then integrate between 0 to infinity, and we have e to the minus st dt. And we are going to integrate this part, because the other part it's already okay. We're gonna evaluate it later together, or we can evaluate this first and work on this later, but I prefer carrying everything down. So let me just rewrite this. Is minus t over s times e to the minus st plus 1 over s multiplied. If we integrate that, we're going to have 1 over s e to the minus st. Okay. Now, again, just to clean up the equation, do a little bit of algebra work. I'm going to put this together. T over s e to the minus st plus multiplying this 1 over s times minus 1 over s will give us the minus. So get rid of this. So this will be minus 1 over s squared times e to the minus st. Okay, then we are going to evaluate that between 0 to infinity. So let's do the evaluation. For the upper limit, t goes to infinity, we're going to have infinity minus infinity over s e to the s times t, whereby t is infinity, e to the minus infinity, minus 1 over s squared, again times e to the minus infinity, minus the lower limit, we're going to have minus 0 over s e to the minus 0 minus 1 over s squared e to the 0. Okay, so we can see that minus infinity, anything that e to the infinity will drive that to 0. Okay, the thing is, if you look at t is going to infinity, and e to the minus st, t is also going to infinity. This is going to 0 first before this one. Hence, once this is 0, it will drive this one to 0. Okay, and again, e to the minus infinity, this is going to 0, that will be 0. So again, this is 0, e to the 0, that one is 1, and this minus times that's going to be positive. So here you have 1 over s squared. Let me just write this properly. So now you can see that the Laplace transform of the ramp input, which is t, is equal to 1 over s squared. So